All right, so on this section, we talked about combining terms, like terms, the last section, and now we're going to talk about multiplying terms. With combining like terms and we're adding, they have to have the same variables to the same exponents. But when we're multiplying, that rule doesn't apply. You can multiply any terms together to get an answer. And in its most basic form, you can multiply terms that are not alike. You just multiply a number by its coefficient. So if we're multiplying 4 times 4x, 4 times 4 is 16, and then we have the x there. 3 times 5y. 5 times 3 gives us our 15, and then that y just remains there. So pretty straightforward in just multiplying a number by a term, which you can do. Just remember, you can't do, like if we did 4 plus 4x, we can't combine those because they are not like terms. But 4 times 4x, we can. So just that distinction of the rule is pretty important. Here's just some examples. 3 times 2x, 3 times 2 is 6, and have the x there. 7 times 3 is 21, and then because that x is there, we just leave it. Here's 2xy, 5 times 2 is 10. 10xy, leave those variables. 3 times negative 5 is negative 15. And then we include that y there. So again, I think it's pretty straightforward. We just multiply them, but we can't, if they're separated by a plus or minus, we can't add them unless they have the same variables to the same exponents. Now, there are terms, obviously, it's not just a constant by a variable term. So we can multiply 4x times 4x. So just like a refresher from our exponents, x times x equals x squared, x times x times x equals x to the third, etc. Like x to the fourth, that equals 4x's times by each other, right? So we need to kind of understand that x to the fourth means x being multiplied that many times together. So we can take a variable term and multiply it by a variable term, and we can kind of break it down in its simplest spots. So this is 4x times 4x, and there's little dots in between them to indicate that they're all being multiplied together. So what we do is we do what we did up here, is we multiply the two whole numbers together. So we have our 4 times our 4, and we have our x times our x. So you can rearrange these any way you want. So if you group the like variable terms together, or variables together in the whole numbers, you can see that 4 times 4 is our 16, and then our x times our x, there's two of them there being multiplied together. We can indicate that with the exponent of 2. All right, just like this example, we have a 5 and a 5. We have an x and an x, and then we have a y here. There's no y in there. So as we break these down, we multiply the whole numbers together. We get the 25, and we have our two x's, which is x squared, and then we have our y at the end there, which you get that answer. So if this makes sense, go ahead and pause the video and see if you can do these, and I'm going to walk through them. So over here we have 3 and our 2, so we can multiply 3 times 2, which is 6, and then this x squared is indicating that I have 2 of them. This x squared is indicating that I have another 2 of them. So if we look at how many we have total, there are 4. So that would be x to the 4th power. All right, so the rule, and we're going to get into this in more detail later in the year, but the rule of when you're multiplying exponents, they have the same base, meaning these are both x, you can add those exponents. Just like over here, we have 3 and a 4. 3 times 4 gives us our 12. And remember, whenever you don't see an exponent, you can imagine there's a little 1 there. We've talked about that earlier in the year. And so I have 1x here. I have 2 x's there. So I have an x times x times x. 2 plus 1 gives us x to the 3rd power. All right, over here, we have 4 times 10, which is our 40. We have an x and an x, which would give us an x squared. Y and a y, there's 2 of them, 2 z's, z squared. Negative and a negative equals a positive, so this will be positive 12. I have 3 x's here, 5 x's here. That gives us x to the 8th power. Now I know this is dealing with just multiplication, but when And we can, remember, we can multiply terms together, and they do not have to be like terms. We just have to kind of rearrange and make sure we're accounting for the exponents that we see there. Without getting too much into the weeds, you can also divide terms that are not alike. Two ways you can see a division problem. One is written like a fraction. So let's say I have 9x divided by 3. Well, this 9 and that 3 can divide out, because 9 divided by 3 equals 3, and then our x on the top there would just remain there. So 9 divided by 3 would be 3x. It could also be written like this, maybe 12x divided by 4. Well, 12 divided by 4 is 3, and then we still have our x right there. We're not going to get into division property of exponents, but you can simplify two terms with multiplication or division, and they don't have to be like terms. So that's a quick review or coverage of multiplying exponents. We combine like terms, now we multiply them, and so as we move forward, we're going to get into what's called the distributive property, where we might have to do both, right? We can multiply terms, and then we would combine terms to further simplify that problem.